Okay guys, this is Britta and we're back with the Odin Project Command Line Basics Part 2. So last time we went through introducing the shell, navigating files and directories, and we have to finish up working with files and directories and pipes and filters. So let's go ahead and jump into working with files and directories. Creating directories. We now know how to explore files and directories, but how do we create them in the first place? In this episode, we will learn about creating and moving files and directories using exercise data / writing directory as an example. We should still be in the shell lesson data directory on the desktop, which we can check using pwd, which we are not. So I am in I'm in home Britter, so then I need to go cd /home/britter/desktop /shell lesson data. No such file or directory. Oh my gosh. Alright, so how am I going to do this? So we need to go to cd desktop, no such file or directory, cd cd /home/britter/ desktop. Okay. ls shell lesson data. So cd I don't understand what I'm doing wrong here. Britter/oh. You know what it is? It's the capitalization of desktop, I believe. Okay. So I keep confusing myself and thinking I'm doing things wrong because I'm not using, which I am, I'm not using the capital of the desktop. So we are now into shell lesson data. So next we need to move into exercise data / writing. So we're going to go cd exercise data / writing. Alright, and that's where we are. So let's do ls-f, and we got haiku.txt and littlewoman.txt, which is correct. Alright, so now let's create a new directory called thesis using the command make directory thesis, which has no output. So we're going to do mkdir thesis. Alright, so now we're going to do ls-f to list all the directories, and we can see that we have the thesis directory there, which is cool. Alright, since we just created the thesis directory, there's nothing in it yet. ls-f thesis. Note that make_dir is not limited to creating single directories at a time. The -p option allows make directory to create a directory with nested subdirectories in a single operation. Alright, so let me make this a little bit bigger here. There we go. Alright. So if we do mk or -p, and then we do /project/data, and then /project/results. The R option to the ls command will list all nested subdirectories within a directory. Okay, so let's do that. And then let's do ls fr. Alright, so now we have haiku.text, littlewoman.text, thesis, and dot thesis. Hold on, let me note that make.dr is not limited to creating single directories at one time. The P option allows make directory to create a directory with nested subdirectories in a single operation. The R option to the ls command will list all nested subdirectories within a directory. Let's use ls-fr to recursively list the new directory hierarchy we just created in the project directory. So ls-fr /project. Alright, so we've got project data and project results. Two ways of doing the same thing. Using the shell to create a directory is no different than using a file explorer. If you open the current directory using your operating system's graphical file explorer, the thesis directory will appear there too. While the shell and the file explorer are two different ways of interacting with the files and directories themselves are the same. Good names for files and directories. Complicated names of files and directories can make your life painful when working on the command line. Here we provide a few useful tips for the names of your files and directories. Don't use spaces. Spaces can make a name more meaningful, but since spaces are used to separate arguments on the command line, it is better to avoid them in names of files and directories. You can use dash or underscore instead. North Pacific -Pacific-gar rather than North Pacific gar. To test this out, try typing make dir North Pacific gar and see what directory or directories are made when you check with lsf. Don't begin the name with dash. Commands treat names starting with dash as options. Stick with letters, numbers, period, or full stop, dash, and underscore. Many other characters have special meanings on the command line. We will learn about some of these during this lesson. There are special characters that can cause your command to not work as expected and could even result in data loss. If you need to refer to names of files or directories that have spaces or other special characters, you should surround the name in quotes. Create a text file. Let's change our working directory to thesis using cd, then run a text editor called nano to create a file called draft.txt. Alright, so cd thesis. Alright, and then run a text editor called nano to create a file. Nano draft.txt. Okay. Which editor? When we say nano is a text editor, we really do mean text. It can only work with plain character data, not tables, images, or any other human-friendly media. We use it in examples because it is one of the least complex text editors. However, because of this trait, it may not be powerful enough or flexible enough for the work you need to do after this workshop. On Unix systems such as Linux and Mac OS, many programmers use Emacs or Vim, both of which require more time to learn, or a graphical editor such as Gedit. On Windows, you may wish to use Notepad++. Windows also has a built-in editor called Notepad that can be run from the command line in the same way as Nano for the purposes of this lesson. No matter what editor you use, you will need to know where it searches for and saves files. If you start it from the shell, it will probably use your current working directory as its default location. If you use your computer's start menu, it may want to save files in your desktop or documents directory instead. You can change this by navigating to another directory the first time you save as. Let's type in a few lines of text. Once we're happy with our text, we can press Ctrl+O. Press the Control or Control key, and while holding it down, press the O key. To write our data to disk, we'll be asked what file we want to save this to. Press Return to accept the suggested default of draft.txt. Once our file is saved, we can use Ctrl+X to quit the editor and return to the shell. So let's open this up, and we're going to put it's not publish or perish anymore. It's share and thrive. Period. Okay. So now we've got that. We're going to press Control and O file name to write, draft.txt, and we're going to hit return. It's not publish or perish anymore, it's share and thrive. Alright, so we wrote it to disk, and then once our file is saved, we can use Control X to quit the editor. Okay, the control key is also called the CTRL key. There are various ways in which using the control key may be described. For example, you may see an instruction to press the control key, and while holding it down, press the X key, described as any of Control-X, Control+X, Control CTRL-X, CTRL+X, _X, C-X. In Nano, along the bottom of the screen, you'll see Get Help, Write Out. This means that you can use Control-G to get help and Control-O to save your file. Nano doesn't leave any output on the screen after X's, but LS now shows us that we have created a file named draft text. So, yep, we got draft text there. Creating files a different way. We have seen how to create text files using the Nano editor. Now try the following command. We're going to do touch my_file.txt. What did the touch command do? When you look at the current directory using the GUI File Explorer, does the file show up? So let's use File Explorer, File Manager. So desktop, shell lesson data, exercise data. Where are we creating this at? Documents? No. It should be somewhere on the desktop. It's not in there. Project. Results. It's not in there. Writing. Oh, there we go. They're both there. Okay. Use the ls-l to inspect the files. ls-l. Alright, so we've got the my file is 0 and the other one's 64 MB. So the touch command created the my file text. The touch command generates a new file called my text in your current directory. You can observe this newly generated file by typing ls at the command prompt. My file can also be viewed in your GUI File Explorer, which we did. To avoid confusion later on, we suggest removing the file you just created before proceeding with the rest of the episode. Otherwise, future outputs may vary from those given in the lesson. To do this, use the following command. So we're going to do rm my_file.txt. Alright, let's do ls, and it's gone. What's in a name? You may have noticed that all of Nellie's files are named something.something. And in this part of the lesson, we always use the extension .txt. This is just a convention. We could call a file my thesis or almost anything else we want. However, most people use two-part names because most of the time to help them and their programs tell different kinds of files apart. The second part of such a name is called the file name extension and indicates what type of data the file holds. .txt signals a plain text file. .pdf indicates a PDF document. .cfg is a configuration file full of parameters for some program or other. .png is a PNG image, and so on. This is just a convention, albeit an important one. Files contain bytes. It's up to us in our programs to interpret those bytes according to the rules for plain text files, PDF documents, configurable files, images, and so on. Naming a PNG image of a whale as whale.mp3 doesn't somehow magically turn it into a recording of a whale song, though it might cause the operating system to try to open it with a music player when someone double-clicks it. Moving files and directories. Returning to the shell lesson data exercise writing directory. Where are we at right now? Writing. Okay, so how do I go back on? Does anybody remember? CD minus? Heck yeah. Actually, it told us how to go there, but in our thesis directory, we have a file called draft.txt, which isn't a particularly informative name. So let's change the file's name using mv, which is short for move. So we're going to do, wait a minute, are we in the right? Yeah. mv thesis slash draft.txt thesis slash quotes.txt. Okay. The first argument, move, tells mv what we're moving, while the second is where it's to go. In this case, we're moving thesis.txt to thesis slash quotes.txt, which has the same effect as renaming the file. Sure enough, ls shows us that thesis now contains one file, thesis quotes.txt, which it does. One must be careful when specifying the target file name, since mv will silently overwrite any existing file with the same name, which could lead to data loss. An additional option, mv-i, or mv interactive, can be used to make move asking for confirmation before overwriting. Note that mv also works on directories. Let's move quotes.txt into the current working directory. We use mv once again, but this time we'll use just the name of a directory as the second argument to tell move that we want to keep the file name but put the file somewhere new. This is why the command is called move. In this case, the directory name we use is a special directory name dot that we mentioned earlier. So we're going to do mv thesis slash quotes.txt dot. The effect is to move the file from the directory it was in to the current working one. ls now shows us that thesis is empty. Yep. Alright. Alternatively, we can confirm the file quotes.txt is no longer present in thesis directory by explicitly trying to list it. So ls thesis slash quotes.txt. No such file. ls with a file name or directory as an argument only lists the requested file or directory. If the file given as an argument doesn't exist, the shell returns the arrows we saw above. We can use this to see that quotes.txt is now present in our current directory. So ls quotes.txt, and it is there. Moving files to a new folder. After running the following commands, Jamie realizes that she put the file sucrose.dat and maltose.dat into the wrong folder. The file should have been placed in the raw folder. Fill in the blanks to move these files to the raw folder, i.e. the one she forgot to put them in. So ls-f shows analyze in raw, ls-f analyze fructose.dat, glucose, maltose, sucrose. Alright. cd analyzed, fill in the blanks to move these files to the raw folder. Move sucrose.dat, maltose.dat. To raw. Okay, I am stumped. I think it's supposed to say raw slash sucrose.dat, maltose.dat. Oh no, you just do // raw. Recall that / refers to the parent directory, i.e. one above the current directory, and that dot refers to the current directory. Okay. I have to remember that .. thing. Copying files and directories. The cp command works very much like the move, except it copies a file instead of moving it. We can check that it did the right thing using ls with two paths as arguments. Like most Unix commands, ls can be given multiple paths at once. So we're going to do, I'm going to clear this out. I'm going to do cp quotes dot text thesis slash quotations dot txt ls quotes dot txt thesis slash quotations dot txt. All right. We can also copy a directory and all of its contents using the recursive option to back up a directory. So we're going to do cp -r thesis underscore backup. We can check the result ls thesis backup. All right, so we got quotations and thesis back. All right, renaming files. Suppose that you created a plain text file in your current directory. To contain, oh, this is just this. Whoops, close it. So suppose that you created a plain text file in your current directory to contain a list of the statistical tests you will need to analyze your data and name it statistics.txt. After creating and saving this file, you realize you misspelled the file name. You want to correct the mistake. Which of the following commands could you use to do so? So, move statistics.txt. I think it's 2. Yes, this would work to rename. Okay, good. Moving and copying. What is the output of the closing ls command in the sequence shown below? pwd users jamie. What is the output of the ls command? The output proteins.dat. Make directory recombined. Move proteins.dat to recombined. Copy recombine slash proteins.dat to proteins-saved.dat. So ls is going to show us move that into recombined. I'm going to think that it's in proteins.dat. proteins-saved.dat. I think it's going to be 4. No. I think it's going to be 1. No. 2. So I was right the first time. So we start in the user's Jamie data directory and create a new folder called Recombine. The second line moves the file proteins to the new folder, Recombine. The third line makes a copy of the file we just moved. The tricky part here is where the file was copied to. Recall that ... means go up a level. So the copied file is now in user's Jamie. Notice that ... is interpreted with respect to the current working directory, not with respect to the location of the file being copied. So the only thing that will show using ls and user's Jamie data is the recombined folder. Okay. Removing files and directories. Returning to the shell lesson data exercise writing directory. Let's tidy this up. So we're shell data lesson data exercise writing. Alright, we're still in here. Let's tidy this up by removing the quotes.txt. So quotes.txt. Alright, ls quotes.txt. Cannot find it. Deleting is forever. The Unix shell doesn't have a trash bin that we can recover deleted files from, though most graphical interfaces to Unix do. Instead, we delete files. They are unlinked from the file system so that their storage space on disk can be recycled. Tools for finding and recovering deleted files do exist, but there's no guarantee they'll work in any particular situation, since the computer may recycle the file's disk space right away. Using rm safely. What happens when we execute rm-i thesis underscore backup quotations.txt? Why would we want this protection when using rm? so that we don't accidentally delete something we don't want. RM, remove regular file thesis backup, text Y. The I option will prompt before every removal. Use Y to confirm deletion or N to keep the file. The Unix shell doesn't have a trash bin, so all files removed will disappear forever. By using the I option, we have the chance to check that we are deleting only the files that we want to remove. If we try to remove the thesis directory using RM thesis, we get an error message. Cannot remove thesis as a directory. This happens because RM default only works on files, not directories. RM can remove a directory and all of its content if we use the recursive option, -R, and it will do so without any confirmation prompts. Given that there is no way to retrieve files deleted using shell, RMR should be used with great caution. You might consider adding the interactive option, RM-R-I. Are we supposed to do that? RM-R thesis and ls. Okay. Operations with multiple files and directories. Oftentimes one needs to copy or move several files at once. This can be done by providing a list of individual file names or specifying a naming pattern using wildcards. For this exercise, you can test the commands in the shell lesson data exercise directory. In the example below, what does CP do when given several file names and a directory? Make directory backup, CP creatures, matchword.dat, creatures, unicorn.dat, backup slash. So it's going to move the, I think it's going to move the, alright, we're in data. Shell lesson data slash exercise data. So we need to go cd dash dash. No, that's not what I wanted to do. cd slash desktop slash shell lesson dash data slash exercise dash data. Did I spell something wrong here? Desktop slash shell lesson data slash exercise dash data. I think I should have put a slash after it. Let's see. cd slash desktop slash shell lesson data slash exercise data. Why is that not working? Okay, now we're where we're supposed to be. In the example below, what does CP do? So we're going to do mk there backup. CP creatures slash minotaur dot dat creatures slash unicorn dot dat backup slash. I messed something up. Sure did. I put CP creatures slash minotaur dot dat creatures slash unicorn dot dat backup slash ls. Alright, so we added a creatures directory and what does CP do when given 3 or more file names? cd creatures ls-f. So right there we made all 3 of those. We made 2 more file names because basilisk was already in there. CP. So if in the below example, we're going to copy those 3 file names, I think. But where are we copying them to? Let's do CP minotaur.dat unicorn.dat basilisk.dat CP target basket is not a directory. I don't understand why it would copy. If given more than one file name followed by a directory name, i.e. the destination directory, must be the last argument. CP copies the files to the named directory. If given 3 file names, CP throws an error because it is expecting a directory name. Okay, so that wasn't supposed to work. Using wildcards for accessing multiple files at once. Star is a wildcard which matches 0 or more characters. Let's consider the shell lesson data exercise data proteins directory. Star.pdb matches ethane.pdb, propane.pdb, and every file that ends with pdb. On the other hand, pstar.pdb only matches pentane, pdb, and propane because the P at the front only matches file names that begin with the letter P. Question mark is also a wildcard, but it matches exactly 1 character. So question mark ethane would match methane, whereas ethane matches both ethane and methane. Wildcards can be used in combination with each other. Question mark, question mark, question mark, ane matches 3 characters followed by ane.pdb, giving cubane, ethane, and octane. When the shell sees a wildcard, it expands the wildcard to create a list of matching file names before running the command that was asked for. As an exception, if a wildcard expression does not match any file, Bash will pass the expression as an argument to the command as it is. For example, typing ls*.pdf in the proteins directory, which contains only files with names ending in .pdb, results in an error message that there is no file called .pdf. However, generally, commands like wc and ls see the list of file names matching these expressions, but not the wildcards themselves. It is the shell, not the other programs, that deals with expanding wildcards. List file names matching a pattern. When run in the proteins directory, which ls command will produce this output? When run in the proteins directory, which ls commands will produce this output? Ethane and methane. So ethane 1, it looks like 1, 3, and 4. No, the solution was 3. 1 shows all files whose name contains 0 or more characters, followed by the letter T, then 0 or more characters followed by ane. This gives ethane, methane, octane, and pentane. Okay, I guess I wasn't paying attention to all 4, what the actual 4 were, so we would still get all of them. Shows all files whose names start with 0 or more characters, followed by the letter T, then a single character, followed by 0 or more characters. This will give us octane, pentane, but doesn't match anything that ends in thane. 3 fixes the problem of option 2 by matching 2 characters, question mark, between T and E. This is the solution. 4 only shows files starting with ethane. More on wildcards. Sam has a directory containing calibration data, datasets, and descriptions of the datasets. Before heading off to another field trip, she wants to back up her data and send some datasets to her colleague Bob. Sam uses the following commands to get the job done. CP dataset backup, calibration, send to Bob all November files, send to Bob all dataset created on the 23rd. Help Sam by filling in the blanks. The results directory structure should look like this. So, copy dataset, backup, datasets. Copy calibration.txt. I'm so confused here. Let's just look at it. Calibration.txt. I was right. Copy 2015-11, send to Bob, all November files. CP -23 data set, send to Bob. Okay, I've made that more complicated than I thought. I thought that I had the right thing, like let's select this, but I didn't know. Organizing directories and files. Jamie is working on a project and she sees her files aren't very well organized. ls-f, analyze fructostat, raw, sucrostat. The fructostat and sucrostat files contain output from our data analyst. What commands covered in this lesson does she need to run so that the commands below will produce the output shown? I think it's got to be analyzed / and raw / I'm not sure. Move.dat analyze. Jamie needs to move her files fructose and sucrose to the analyzed directory. The shell will expand dat to match all files in the directory. The move command then moves the list of dat files to the analyzed directory. Reproduce a folder structure. You're starting a new experiment and would like to duplicate the directory structure from your previous experiment so you can add new data. Assume that the previous equipment is in a folder called 2016-05-18, which contains a data folder that in turn contains folders named raw and process that contain data files. The goal is to copy the folder structure of 2016-15 folder into a folder called 2016 so that your final directory structure looks like this. So, which of the following set of commands would achieve this objective? What would the other commands do? Okay, so this is, you're going to make the folder, we're making the folder / data, and then we're making data process and making this. Make directory, copy data 2016. Do we want to copy the data files though? Just the folder structure. So we don't want to copy the actual data, I don't think. So the first two sets of commands achieve this. Okay. The first set uses relative paths to create the top level directory before the subdirectories. The third set of commands will give an error because the default behavior make directory won't create a subdirectory of non-existent directory. The intermediate level folders must be created first. The fourth set of commands achieve this objective. 1, 2, 3, 4. Remember the P option followed by a path or of one or more directories will cause makedir to create any intermediate subdirectories as required. The final set of commands generates the raw and process directories at the same level as the data directory. Key points: CP old new copies a file. Makedir path creates a new directory. Move old new moves renames a file to a directory. RN path removes and deletes a file. Star matches 0 or more characters in a file name, so .text matches all files in the end .text. Question mark matches a single character in a file name, so question mark .text matches a .text but not any .text. Use of the control key may be described in many ways, including Control-X, Control CTR-L-X, and X. The shell does not have a trash bin. Once something is deleted, it's really gone. Most file names are something.extension. The extension isn't required and doesn't guarantee anything, but is normally used to indicate the type of data in the file. Depending on the type of work you do, you may need a more powerful text editor than Nano. Okay, so we have done that, and now we need to do pipes and filters, and let's see how long this is. This is quite a bit of information, so this one's going to actually have a part 3 because we're already looking at 40 minutes because that took a long time. But I will see you guys on the next one.